So that gives us a good idea of what cosine looks like. So now that we know what the regular sine graph looks like, the regular cosine graph looks like, now we can tinker with them a little bit, just like we have done with other graphs. But we now also have to be careful that we use our terms properly, is that we have a period that we're worried about and an amplitude that we're worried about. So for right now, when we're graphing, those are the two things that we're going to find first, and then we're always going to fill in our 5 points. So for amplitude, we've got the absolute value of A, where A is the number that's out in front of either the sine or the cosine. It's just like A when you had a quadratic equation. It's always the first number you see that's out in front. Notice the absolute value means that you're always going to want to take whatever that number out in front is and make it positive. So amplitude is always positive because of those absolute values. So amplitude is always positive because of those absolute values. A isn't always positive, but the amplitude is. And how we're going to find period, meaning how long it's going to take us to repeat our graph, whether it's sine or cosine, is we're going to take 2 pi, which is our normal period that we have for just an ordinary sine or cosine graph, and divide it by the b. And b is going to be the number that's out in front of the x that's inside of the cosine in the sine function. So we're going to divide by the 2 pi by the b, and that won't change. That formula is going to get used over and over and over again. So the first thing that we'll find is we'll find our period and our amplitude first, always. Then after we find our period and our amplitude, we'll draw those things in, and then we'll find our 5 key points that we were talking about. For the cosine, we start at our peak and work our way down to our minimum, and then work our way back up to the peak we started at. For our sine graph, we start at 0, go up to the peak, then come back down to our minimum and work our way back to the center where we started. And we'll work on how you figure out those 5 points, because you do need to know where they happen. You do need to know the x values where they happen. We need to find all these x values. And that is even important in my math lab, because they'll have slight variations with different numbers. So you need to know which ones are right, even if they do choose to give you multiple choice graphs to choose from. But they can also have you graph your own graphs in my math lab. So what we'll do is we'll plot our 5 key points, make sure that we know the values along the x-axis, make sure that we also know our heights here, our highest points and our lowest points, which are going to be determined by the amplitude. And then we will play connect the dots and make sure that we put our arrows at the end of the graphs to make sure that we know that the graphs keep on going on forever. And this is something you may want to actually draw in on your scratch paper, so that's a way of showing work for these. It's really up to you, though, how much you want to show. It just depends on how confident you are with your graphing. Because, just as a reminder, any of this stuff that I'm graphing like this is going to be on a non-graphing calculator portion of your test, which means you should be able to do this without a graphing calculator by hand. Let's take a look at an example. Let's start out with this first function. In this first function, we have y equals 3 sine of x. Well, first of all, before you do anything, we should be working on how do you find your, first of all, we need 2 things. We need the amplitude and we need the period. So one thing at a time, let's work on that. First of all, let's find our amplitude. Well, remember the amplitude is the absolute value of whatever your A is. And if we have y equals 3 sine of x, our amplitude is going to be the absolute value of the number out in front of the sine, which is, in this case, 3. So we'll be doing the absolute value of 3, and I know 3 is positive, so the absolute value of 3 will just be 3. What does that mean, though? Remember, the amplitude tells us what is going to be the distance between the middle of our graph and the highest point in our graph. So our highest our graph should go is 3, and the lowest our graph should be is -3. And we're just going in units of 1 here. All right. The next thing we need to focus in on is what is our period of our graph. Well, let's see. Our period of our graph, remember the period formula? The period formula is 2 pi over b. And remember, the b is whatever number's out in front of the x. Well, I don't see a number out in front of the x, so remember that means that there's a hidden 1 there. So that's going to be our b. So we'll plug in a b of 1. So that will be 2 pi over 1. Well, anything divided by 1 stays the same. So that means our period is just going to be 2 pi, which is good. So that means if we start our graph at 0 like we would normally, we won't repeat ourselves again until we hit the very end here of our first period, which is 2 pi. So now how do we find the x values for the 5 points? We've already got the first point at 0, and we've got that the last point should be at 1. Remember, with the sine graph, we said the sine graph always starts at the center at 0, at 0, 0, which means it's going to end at the same point at 2 pi because that's its period. It's got to start and end at the same value. Okay. Remember, we were drawing 5 points, so this is perfect. Our next point, we've got 3 more, which will be broken up into evenly spaced, which is what normally happens. Our next point should be going up. That's how the sine graph works. That's the pattern. Should be hitting the maximum at 3. Then it's got to hit halfway in between the 0 and the 2 pi. It's got to come back down to hit the minimum somehow, so it's got to hit 0 in the middle. Well, we know that if this is our halfway point and the beginning of our graph was at 0 and the end of our graph was at 2 pi, then the middle has to be half of that if you were in the middle, which would be just 1 pi. Getting there. And after that, we have to at some point hit the minimum before we come back to the 2 pi where we go back to 0. So I've got to hit the minimum at -3 next. So that gives me at least my pattern that I need to follow, which is our going up to hit the max. Then I have to head back down towards the minimum, hitting 0 in the middle, and then come back up to where I started. And I'm going to throw arrows on the ends of my graph. And I'm almost done. The only thing now that I need to do is fill in what are my values at the 2 values in between, where our peaks are, where our peak is at 3 and where our bottom is at -3. Well, if we're going to be, look, halfway in between 0 and pi, well, halfway in between 0 and pi is pi over 2. The next one would be, well, what's halfway between pi and 2 pi? Well, that's 1.5 pi, which is, we remember from our unit circle, 3 pi over 2. And that's all they wanted. Now, I will say, at least if they say they want 1 period, we're done. However, notice that this graph said that we were supposed to go all the way up to 2 pi, which we did on the one end. But they also said that we want us to go all the way to, -2 pi on the other end. So I'm going to put my -2 pi on the other end as well. So I'm going to put the -2 pi that they want us to go up to on the other end, and I'm going to continue my graph. Remember, basically, it's going to repeat the same pattern that we just did. all over again, but on this side of the graph. Well, notice it was headed down here. So it was headed down to our minimum. And notice that does match up with what was going on the other side. So these 2 points match up. And then the next thing we're kind of working in reverse because these two matched up. So the next point would be hitting the x-intercept. So we'll work our way up to that. The next point would match up with hitting our peak at 3. And remember, I'm repeating pattern. I have to come back down to 0 where I started. And so I come back to 0 where I started. And just to continue my graph on forever, just to show that it does. And if they wanted these values, I can fill them in. Notice it's basically the same thing that happened on the other side, just negative values of pi. So this halfway point would be a negative pi. The middle of the 0 and the negative pi would be negative pi over 2. The middle point of the negative 2 pi and negative pi would be negative 3 pi over 2. And that gives us an idea of what's going on, not for one period, but for 2 periods, because you actually see 2 copies of this pattern. That's how you know you actually have 2 periods, not one.